Hi Year 12, welcome to another lesson. I'm not sure if you will be doing this lesson before or after you've been in for the lesson with Mr. Little, but this is just intended to be part of lesson 1 this week for me. So before we went into lockdown, we had started Unit 4, which was hardware and software. So we'd done some work on what is hardware and software. We looked at different types of software, including operating systems, and we may have just started looking at programming language classification. Firstly, I apologise if I go over this and I've already done it and you understand. Just consider it a bit of revision. But for those of you that maybe didn't or don't remember doing it first time round, this lesson is for you. But go through to the end anyway, because there are some tasks to do. So I suppose here's to figure out what you do or don't remember. How many of these questions can you answer confidently? You might want to pause the video once the questions are on and have a go at jotting those answers down, and then you can tick them off at the end. I'll put the answers up at the end of the slideshow. So what are the main types of programming languages? Which type of language uses zeros and ones? And which type of language uses natural language keywords? Are you happy with those questions? Could you answer them all straight away? Or is it taking a bit of time? Which ones are you unsure on? If you have been into school this week, you hopefully have been given this book by Mr. Little. If you want to refer to notes in the book to help you with this lesson and future lessons, currently pages 72 and 73 will be quite helpful. If you've got the Bob Reeves textbook, we are looking at chapter 29. Sorry. So, types of programming language: machine code, assembly language, and high-level languages. Let's go through machine code first. So this is the lowest level of code. It is closest to the processor. It uses zeros and ones. So as in that's how the code is written. It would just look like binary data to us, just zeros and ones. And it is written specifically for a particular processor, which means it's not portable. If you are writing instructions in machine code, you are doing that for a specific piece of hardware, a specific processor. It is, however, executed very quickly. Assembly language, again, it is considered a low-level language. However, it was developed because the machine code written in zeros and ones is really difficult to understand. It's difficult to read, it's difficult to edit and to follow. So assembly language was developed because it uses mnemonics, so sort of 3-letter abbreviations sort of to represent the different commands that you might use, which makes it a little bit easier to put together. You may remember we had a look at some of these. I may set you some tasks to have a go, possibly next lesson. Assembly language would be converted to machine code by an assembler. And then high-level languages, I just put that one in there so it balanced out. High-level languages, they use English keywords, which make them much easier to understand, but they will still be translated to machine code by either an interpreter or a compiler. And again, we will look at those in more detail next lesson. So this is the diagram that is in the revision guide, the pink book. And it's just there to show you the different my pointer here. So down here, this is as close to the processor as you'll get. So this one, we can see the binary instructions there. So it uses zeros and ones. It's the lowest of the low level languages, which means it's machine code. Okay, the next one up here, these are the mnemonics that we talked about, which represent different instructions. And this is our assembly language. And then the high level language at the top uses the English keywords. So we can see here that this, which looks like it's written in Python, we have new score equals score minus 10 and then print new score. And down here, LDA score, okay, so it's going to load the score, it's going to subtract 10, and then it's going to store the new score and output that. And then the same instructions here are written in binary, and as you can see, very difficult to understand there. You know, if you needed to change that, maybe you wanted to have it as subtracting 5, not 10, it would be much harder to go into this machine code to edit that than it would for either of these two here. Okay. So, advantages of high level versus low level. As we've just seen, it's much easier to debug or to change, maintain programs because it's just easier to understand them. And it's also quicker to write those programs, and much easier to write those programs. We've got a number of different high-level languages that have been written specifically for different types of problem, and that is one of the tasks, one of the other tasks I'm going to ask you to do this week, is to do a bit of research into a particular type of programming language, a high-level programming language, and find out why it was developed, why it was created. And finally, high-level language programs are portable, so you can write a program for one type of computer, and then it can be recompiled for a different type of computer. The disadvantages, though, are that obviously the object code, which is the compiled or the interpreted code, so when that's what we call it when you have your program that's written in a high-level language, and that has to be, as I say, compiled or interpreted. We call that the object code, that resulting code. That might likely run slower than assembly code or machine code. And that object code would probably occupy more space in the RAM as well. Now, if that was an embedded system, that would be a problem because they have limited amounts of memory. So, hopefully a quick look at those, and how many of those questions now could you answer confidently? And as I said, I'll put the answers up for you. So we have the main types of programming languages there, which one uses zeros and ones, and which one uses natural language keywords. So what I want you to do is to have a look at the accompanying task that comes with this, bit of research, a couple of questions, and then you can submit that to me hopefully by the end of the week. Okay, remember, any questions, if there's anything you didn't understand or want me to go over, just email me and I will do my best to help you out. Okay, thanks a lot. I'll speak to you soon. Take care.